Respected fellows, welcome to my channel Curious Solver. Today we are going to perform a simulation on 2D, or we are going to learn a simulation of 2D fluid structure interaction on ANSYS Fluent software. The first step is to open the workbench. For this we go to the search bar, type the workbench and then open it and wait for the window to appear in front of us so we can start our simulation. As you can see, the toolbox window is open. So from the toolboxes we select the fluid flow fluent and then drag it to project schematic. First of all, we have to make the geometry in 2D or 3D, or do an analysis in 2D or 3D. For this we go to properties and select 2D, as our simulation is 2D, and then we will open the design model. You can make the geometry in SolidWorks, Creo, NX Siemens, or any other software as well, and then import it in IGES or step format. As you can see that first I change the units to millimeter, and then select the XY plane and go in the sketching and sketch the solid part, and then I will sketch the fluid part. As you can see, after giving dimensions to solid part, I go to concept and select surface from sketch, and from there I select the sketch one and to the base object, so that I can make it into a 2D body, or convert the sketch into 2D body. And in operations I select it as add frozen. The advantage of add frozen is that when we make more than one part, it will separate each body. Now I will sketch another part, that is the fluid part, and then I will give its dimension, and same process I will do that. Go to concept and then say that surface from sketches, and give this sketch or make this sketch into a 2D body form. Let's see. You can see that I am giving dimensions. Now in base objects I will select the sketch 2, because fluid is sketch 2, and then can go on operations and separate the solid part from the fluid, so that both bodies can be separated from each other, and preserve the tool body, because we have to use the solid body in fluid structure interaction, so we can't delete it. And then we will close the design model, and then we will save the project on desktop in the folder Query Solver. You can save it according to your requirement. After saving the project, I will open the mesh by double clicking it, or double clicking the tab of mesh. As you can see, my mesh window is open, but in later you can see that in contacts and they will contact a pair in that. If we will choose it as like this, then we have to go to the mesh interface and do the coupling of the wall. To avoid the coupling of the wall or to make the conformal mesh, I will close the meshing and then go back to our geometry and make that two bodies into one part. As you can see that I am going to the geometry. Now I make these two parts into one part so that the contacts between a pair don't appear between them, or you can say that the conformal mesh appear make between them, or you can also say that or understand that it will take it as a single body that have more than one part. Now we will open the machine. As you can see that in contacts, now we don't have the option of connections because it will automatically assume it as a uh, coupled wall. See, okay, now we will create the mesh. As you can see, the automated mesh is very rough, so we will decrease the size of the element. So we can, after decreasing the size of the element, we will see that the mesh will get refined, a little refined. I will take the mesh element size to 2 mm. Now it's time to give the name section of boundary conditions, inlet, outlet, fixed layer to the bottom of the solid body. The fixed layer is basically the layer at which our body is attached. For example, if there is a beam, the beam one end is attached to the ground. Similarly, we have to fix one point so that it will oscillate, the body can oscillate around that point. And then we will give the name to the wall of the solid body. The wall solid body is basically a wall that have to deform, or we will observe the stress on that part of the body. As you can see that we give the four boundary conditions, the other wall will automatically detected by the Fluent software. We will close the meshing, and in after closing we will update the setup part. After updating, we have to right click on the setup and then start the case, and then wait for the window to appear. During that time, don't click mouse randomly because it will hang your system. So avoid it and wait the front window to appear. As you can see, the window is appeared. Now first we will run the fluid flow simulation without structure interaction and the steady state simulation, and for that purpose As you can see that there is one issue that the fluid is a single body, so we will go back to the mesh and make it into two parts. Under the sensor condition, you can see that it takes the two bodies as a single. So we will go to the mesh part and name the solid body and fluid body in the name section. So it can be paired in the fluid like that, because we have to define separate materials to, or separate yes, materials to each body, one to air and the other one to rubber. As we assign them, then now we will close the machine. After closing the machine, right click on setup and reset, so that you can now you have to update the setup so that the mesh updated mesh will be transferred to the setup with boundary names or name selections. As the mesh has been transferred to the setup, uh, on the bottom left side you can see that the red sign is not appeared. Now right click on the setup and start your Fluent and wait for a minute to appear the window of Fluent. First we run the steady state simulation with the default viscous model and default materials, and give the inlet velocity to 30 meter per second. This is only the fluid flow. We currently we are not doing the simulation of fluid structure interaction. And then initialize, do the hybrid initialization, give 1000 iterations or 10,000 iterations, but in few iterations it will converge. You can see on the window it is solution is completed. Now I would like to try to open the fluid structure interaction, but I want to clear one thing, that in Workbench a fluid structure interaction is not supported in Fluent. So we will export this case to and data, so that we will open a separate window of Fluent, and in on a separate window we will run the simulation of fluid structure interaction. As you can see that the warning sign you can see on the window, the structure model is not available in Workbench. So we export the case in data on desktop named query solver, name of my channel in the folder. You can name it according to your choice or requirement. Now I am opening the Fluent standalone software. Standalone software support this thing. Now I will import the case. First step is to import the case. And one thing is clear, that in Fluent Launcher you have to select the solution, not the meshing one. Okay, and then start and wait for the window to appear. Now you will have to import the data file. It is your choice. If you even not import it, it doesn't matter. I'm just importing it to verify that my case is okay. Now I will go into the structure models and select the linear elastic. But before that, I have to change the properties in solid. You can see that I can only put in the density, but I have to also put the value of modulus of elasticity or Poisson ratio. So on structure, I will just select the structure model, linear elastic. We have the option of two different models, but we are using the elasticity, and we are now giving the properties of rubber, that is hypothetical properties. You can choose according to your requirement. Even on aluminum, steel, you can observe the structure analysis, do the structure analysis and observe the stress and displacement as well. I am just using the rubber because in rubber you can see the deflection much more with the small force or a small velocity as compared to the others and metals. And in walls, first of all, I have to give the nodal displacement to 0 to the fixed wall, a fixed point of the solid body. You can say the fixed line of the solid body. And then I have to select the surface of the wall that is attached to the fluid domain or adjacent to the solid domain, as you can see on the window. And I will give it to the or say it to the intrinsic FSI, because at that point, at that wall, we will face the stresses due to the velocity and the deformation or displacement within the solid body occurs. And in dynamic mesh, we have to tell that which wall should be stationary or which wall should be intrinsic FSI or subject to fluid structure interaction. And for this, we will select the linear elastic model. And you know that inlet, outlet, both are stationary. So, but the small body, that is the I-shaped, should be subject to intrinsic FSI, and the wall is also stationary of the channel wall. We don't have to give the fixed layer stationary because it is also already defined in nodal displacement. Now I will run the simulation. But before in controls, I have to check which equations I am solving. Uh, you can see that I am solving the flow, turbulence, and structural equation. And in run calculation, it is already Fluent run, so we just have to check the displacement. So we will within 1 to 2 iterations, it will converge. And in structure under the displacement, you can see the displacement within the body. The value is appeared in the form of contours. You can see. Now I will export this steady state simulation results of fluid structure interaction. After that, I will run the transient simulation by exporting this results. It is not a necessary step, but on safe side, so that I don't have to do setting from the scratch. if I do any mistake. So I save it a copy of this solution. In transient, you can see I just select the transient from the journal and then do a hybrid initialization. And in calculation activities, if you want to make any animation for this, you can do it on here. As I want to make animation of total displacement and displacement in extraction. So I will make the animation of these two contours. Now in run calculation, I give the time steps and then the time step size. The time step size, you can get it by experience, and usually for such a small deflection, you usually use a very less or a small size of the time steps. Now you can see that with the flow, I am not making the contour flow, but you can see the deflection in the eye shape, and bottom end is fixed. You can even make the velocity of the contours, but we are not making it on here. You can do as much post processing as you want according to your requirement. If you want to make get the results in form of numbers, you can go in the report definition and get the area weighted average or a max value of the displacement as well. Now I go to the playback and you can see I will run the simulation. I will run the animation, and you can even save it by clicking the right. That I am not doing. I am not saving it because it's not my requirement. So thank you. This is the tutorial. Thank you. This is the tutorial from my side. For paid help, only for research purpose and for research collaboration, you can contact me at querysolver@gmail.com, or you can type a comment under this video. Thank you.